Hi viewers, welcome to LMS Solution. Today we are going to see about 5 kilowatt single stage grid connected PV system in MATLAB Simulink. So here you see that this is a simulation model we developed for 5 kilowatt single stage grid connected PV system. This model consists of PV array. So this PV array having one parallel string and 24 series connected model, and single panel will be generating around 215.17 watts, and voltage at maximum power point is 28.96 and current at maximum power point is 7.43 amps. So it will be generate the maximum power at a standard test condition is around 5 kilowatt. Here you see that it will be generate around 5.164 kilowatt and rated at 695.04 volt. This value going to be changed according with the change in irradiation condition also. When I click this point, and at 100 watts per meter square, the power will be find in watts. This irradiation change in the power, the peak power also going to be changed. Now that PV array directly connected to the inverter. Here we are using a universal bridge. This universal bridge acts as a 3-phase inverter. So the PV directly connected to the inverter. So there is only one stage. So we are converting the DC into AC by means of this voltage source inverter. So that is known as single stage grid connected PV system. And then this inverter connected via this LCL filter to the grid point. So this is a grid point. Grid is rated around 400 volt and 50 hertz. Now we need to control this inverter in order to convert the DC power generation from the PV and AC power, and the AC power should be sent to the grid point. For that we go with feed forward decoupling control. For that we need to use MPPT. Here we are using P&O MPPT algorithm. The P&O MPPT will be receive two inputs. One is PV voltage and current. According with the PV voltage and current, it will be generated the V reference. So when go inside that P&O MPPT, so here you can see that the code for that P&O MPPT. Here we are receiving that voltage and current of the PV array, and then here we need to fix the reference voltage maximum, minimum, and initial reference voltage, and small change in or increment voltage levels. And then here we need to fix the initial voltage, power, and reference voltage. And then here we are going to calculate power, change in voltage and change in power. And then we need to check the conditions. So here we need to condition for the P&O MPPT algorithm. The P&O MPPT algorithm having 4 rules. According to the 4 rules, that voltage will be going to be increment or decrement. So according to that 4 rules, we need to that when P&O MPPT will be provide the reference voltage. So here we are getting reference voltage. So this reference voltage will be compared with the PV voltage, and then it going to be processed via PA controller. So this PA controller acts as a voltage controller. That means it will be control this voltage across this PV according to the reference voltage. Here we are adding another parameter, nothing at the power generation current. Here we are calculating PV power. Here we are measuring the PV power, and then we need to convert it into current. Further you have to multiply it with 2/3 and divide with the VD. So VD nothing but the direct axis voltage or peak voltage of the system, that means AC system. And finally we are getting the current reference. So this is the current reference. So this current reference is compared with the ID. So for ID and IQ and VD, here we are measuring the grid voltage VABC. So that will be processed via PLL. So here we are having omega t. So this omega t used in the power transformation to for converting the VABC to VD VQ. I inverted into ID IQ. Here we are having a direct and quadrature axis voltage and current in the grid side as well as the inverter side. So this ID only we are taking here. After this is a reference current, this is actual ID current, and it going to be processed via PA controller. And then here we are applying feed forward decoupling control concept. IQ omega L plus VD, and then you have to multiply with 2 and then divide with the VPV. Same way here you see that this is for a quadrature axis current control. Here we are taking that IQ reference will be 0, and then it's going to be compared with IQ, and again process via PA controller, current controller, and here you are using ID omega L and VQ, and then you have to multiply it with 2 and divide with the VPV, and finally we are having control voltage in the form of VD and VQ. Finally we need to convert this VD VQ into ABC form. Here we are applying inverse power transformation, because here we are applied a power transformation, and here you need to apply inverse power transformation, and finally we are having control voltage. The control voltage should be processed via PWM generator. This PWM generator, that means sinusoidal PWM generator, it will be generate the pulse. So this pulse will be used to control this voltage source inverter. The total system, that MPPT and total this voltage and current control, it will be convert, that means it will be send the DC power to grid according with this control logic. So here we are measuring the PV voltage, current and power, and here we are measuring the point of common coupling voltage, current at the inverter power, and then this is a grid voltage, current and power. Just I am going to simulate the model. Now you see that this is a PV voltage is around 700 to 695. So this is a PV current, and then this is a power generation from the PV power generation is around 5.1 kilowatt. So this is a point of common coupling voltage. So this is inverter current. So this power from the inverter is, this is also comes under 5 kilowatt. So this is a grid voltage, grid current and grid power. So grid is receiving power from the PV system. So at the time of 0.3 second, here we are varying the radiation from 1000 to 500 watts per meter square. So you have to check the result. Now see that the PV power generation comes around 2500, and also this is a variation of PV voltage and current. According with this PV voltage and current, the power injection to that grid also reducing. Whatever power generated from the PV, so that will be sent to that grid system. So this is PV voltage, current and power. This is inverter voltage, inverter current, and that inverter voltage after filter. So this is inverter current, this is inverter power, this is grid voltage, grid current and grid power. So in this single stage system, single stage grid connected system, this water power we are generating from the PV, that will be sent to the grid by means of this MPPT algorithm, as well as this and feed forward decoupling control concept. So this is the working of this model. So thanks for watching our videos. Kindly subscribe our channel and also bell icon for notification about upcoming videos. Thank you so much. Bye bye.